Right, so we now deal with differential equations. Some of you have already been dealing with a few examples, but I'm just going to repeat. Okay, so your differential equations, you can see that this is a first derivative here, dy over dx. So at the moment, these are all first derivatives. Right, so what we're going to do here is we need to go back to that original equation. What was it? So if an equation has already been differentiated, how do you get back to what it was? You do the inverse operation of differentiation, which is integration. Right, so now let's go back. Let's start with the first one. So in N5 maths, we only do direct integration and separating the variables. Right, then in N6, we will do other types. We will do first order linear differential equations and second order. If you're going to a university of technology or any university, there's many other types of differential equations. It gets much more involved. Right, so, but it all starts here with the basic stuff. So let's take the first one. So what do we have? I have dy over dx is equal to 2 minus y all divided by 3 plus x. Okay, so now I cannot do this by direct integration because the problem is I have both y and x in the same on the same equation here. You can see that. So now I'm going to separate the variables. What do I mean by separate the variables? I'm going to get all the y's on one side, all the x's on one side. So let me just cross multiply first, get rid of the fraction. So that's going to be dy multiplied by 3 plus x is equal to 2 minus y multiplied by dx. So I got rid of the fractions. What did I do? I just cross multiplied them. In other words, I multiplied by 3 plus x on both sides, and I also multiplied by dx on both sides. Right, but I just did it in one step. Now, when you separate the variables, you cannot have dx in the denominator or dy in the denominator. dy must always be on the top, on the left-hand side, dx on the right-hand side. Or if you swap it around, it doesn't really matter as long as it's separated. So now, there's a problem here. This is dy. That means I need to integrate the left-hand side with respect to y in order to get to that original function. On the right-hand side, it's dx. We got a problem. This is dx. I cannot have any y variable here. This is dy. I cannot have any x variable. So I need to get this 2 minus y on the left-hand side with dy. And I need to get the 3 plus x on the right-hand side with dx. So what am I going to do? I'm going to divide by 2 minus y. So I have dy all divided by 2 minus y. So what did I do? I'm dividing by 2 minus y. And this I'm going to divide by 3 plus x, and it goes to the right-hand side. So this is going to equal to dx all divided by 3 plus x. Right, so I divided. Now, so the variables are now separated. That is the aim here. Your variables are now separated. So, what can we do now? Now, we can integrate both sides because that is what we want. We want to get to that original. So I will go integral on both sides. So I'm integrating the left-hand side with respect to y. There's my dy there. I'm integrating the right-hand side with respect to x. There's my dx there. Now, okay, there's a dy which I'm writing down here. So what is the number in front here? It has to be a positive one. It cannot be a 0. So this is a 1 all divided by 2 minus y, and here this is a 1 all divided by 3 plus x. So now you can see the left hand side you have a fraction, right hand side a fraction. So this is a revision of your integration chapter 4. So what do we have here? You must at this stage be able to do this one time. Okay, but let me just refresh your memory now. So both these are fractions where the numerator is a derivative of the denominator. So what do I mean? You got f prime x on the top, f of x in the bottom, and you know that if the numerator is an exact derivative of the denominator, then the answer is always ln absolute value of the denominator plus c. Okay. Now, let's look at the right-hand side. The right-hand side matches this 100% because if you look here, I've got 3 plus x, which is my function of x in the bottom. And is this the exact derivative on the top? Yes, the derivative of 3 is 0. You can't see 0. But the derivative of x is 1. So that means it satisfies this condition. So therefore, the answer is going to be, well, you know there's just a 1 in front here. So it's going to be ln absolute value of the denominator plus c. The problem here, a small problem on the left-hand side is that the numerator is not a 100% exact derivative. I'm talking about the constants there. So the derivative of minus y is what?
It's minus 1.
It's minus 1. So by inspection, now there's two ways to do this here. By inspection, if I put a negative here, I need to cancel that negative by multiplying by a negative or dividing. Well, with 1 you can multiply, divide, you're going to get the same thing. Only with the number 1. You don't try it with anything else. So negative times a negative must give you that positive. So now what did I just do? I have my k, which is a constant in front, my exact derivative on the top, and my function of y in the bottom. So in one step, I will go k, which is minus 1, ln absolute value of the denominator, and you only put plus c one time. Okay, there's no, because c just represents any number. It could represent 1,000 numbers too. Okay, so what happened here? You do not have to go any further. It is possible to go further, but in N5 we don't require that. So as long as you integrate, then now this is called the general solution. So that is the general solution. Right, so let's deal with the next. It's all about manipulating the formula correctly first, and then go back to your chapter 4 work, which is integration. Let's deal with the next one. So this is a general solution. We still have plus c here. Right. When we deal with the particular solution or unique solution, we will be given values, which we will do in a few minutes. But let's deal with these examples first. So B, what is B? Now, separate, let me give you a few minutes there. Manipulate that equation, separate the variables. Right, so let's have a look at the next one. You've got a fraction, again, fraction on both sides. So when you have one fraction on the left, one fraction on the right, to get rid of the fraction, just cross multiply in one step. Okay, so I'm going to cross multiply. So that's going to, when I cross multiply, remember it's numerator on the left, denominator on the right. So top left multiplied by bottom right. And then you got top right multiplied by bottom left. It's a cross. You just follow the cross there. So that's going to be dy multiplied by x is equal to the square root of 1 minus y squared multiplied by dx. Right, so I cross multiplied. Now remember that you cannot have dx in the denominator or dy, and it must always be on the top. So what do I need to do? I've got dy on the left hand side. I need to divide by the square root of 1 minus y squared, so it's going to come in the bottom there. You're clear with that? Then I need, this is dx on the right, so I must divide by x, and dx and x will be in the denominator. So now this will be dy all divided by the square root of 1 minus y squared is equal to dx all divided by x. So you must do many examples to get used to the manipulation, yeah? So in the exam you mustn't be confused. You manipulate it once, depends on what question you're given. So now variables separated. We separated those variables, now we need to integrate. So I'm going to integrate both sides, the left hand side with respect to y, the right hand side here with respect to x. So you are putting in the integration sign there. There was no integration sign, you can see that. After you separated, you introduce the integration on both sides. That's basically what you are doing. So now, on the left hand side, what do I have? I have 1 divided by the square root of 1 minus y squared. And on the right hand side, I have 1 over x. So now, let's see our integration. The right hand side, let's check the right hand side. The right hand side, 1 over x satisfies this type of integration, division, where the numerator is an exact derivative of the denominator. You must realize that in 1 second when you look at it, okay, that you can see that the top derivative of the bottom. Obviously, you must know your differentiation. Now, the left hand side is a fraction, but it does not satisfy this condition here. Can you see that? It does not. Because the derivative, if you differentiate the square root of 1 minus y squared, let me just show you what I'm talking about. If I got the square root of 1 minus y squared, which is the denominator, you know that this is the same as 1 minus y squared all raised to the power half. If I have to differentiate this here, then it's going to be half 1 minus y squared, and half minus 1 is minus half times the derivative of minus y squared, which is minus 2y. And all this is definitely not 1. This is not 1. So it is not an exact derivative. So it does not satisfy this condition. So what do we do? So we need to remember now. There's certain types. After you're done with all the exact derivative types, then what other topic did we deal with? We dealt with special cases, and then use, obviously this applies to inspection. This is the inspection what I'm doing, or use substitution. Then when inspection and use substitution fails, then we use trigonometric substitution. So this involves trigonometric substitution, but we are not going to go and derive the whole thing. We go to the formula sheets, and this is what you are looking for. Right, so you are looking for, let's see, how is it given to you on the formula sheets? We got 1 over the square root of a squared minus x squared. This is how it's given to you on the formula sheets. Okay. I'm writing it down as it is. Although this is y, but on the formula sheet, it's just given to you in terms of x. So if you see this, then this involves sign substitution. You look for this, and this is equal to inverse sine x over a plus c. Okay. If you were given 1 over a squared plus x squared, I'm just refreshing your memory on inverse trig functions. This is a tan substitution, so this is going to be 1 over a inverse tan x over a plus c, and there are 6 of these ones here, okay, on the formula sheet. There's 6 because you know there are 6 formulas for differentiation. That means there must be 6 for integration also. Alright, so now here you notice there is no b here. Like in N6, it's much better. Right, in the N6 formula sheet, let me just show you, for those of you who maybe had a look at what's happening in the N6. Yeah, so I got a squared minus b squared x squared. Right, so this is how it's given to you in N6. I'm looking at these two here. It's the same formula, it's just that in N6 you always have the b there. So then the difference will be 1 over b inverse sine bx over a plus c. Right, so whatever I'm writing down, you already have it. I'm just refreshing your memory now. You must recognize that when these techniques fail, then it's trigonometric substitution. Right, so the first one is the one that we are using now. So let me change it now. Let's make it y. Because we are using y, so that will be y over a plus c. Can you see that? Instead of x, it's y now. So what do you do in this situation? You will write it all as perfect squares. There you can see a squared minus y squared. So the 1 can be written as 1 squared. 1 squared is 1. 1 squared means 1 times 1. Okay, so that's your 1, which is a. There's your y there, and this is how you follow it. This is inverse sine. So let me go straight. This was the formula that we're going to use. So from here to here, this is going to be inverse sine of y over a. So that's just y over 1. Y over 1 is just y. That is my left hand side. Right, on the right hand side, this is exact derivatives. And that's what we're doing there. The numerator is an exact derivative of the denominator. So that's going to be ln absolute value of x plus c. And this is your general solution. Right, so that was B. Let's deal with the next one, C. So we need to separate those variables. We need to get all the y's on one side. Let me give you 1 minute to try and do this. Right, example C is different from A and B because you've got a fraction on the left hand side, but the right hand side is not a fraction. So you can't just do it in one step where we cross multiply. Can you see that? So you must recognize that on the right hand side there's a plus sign separating two terms there. Can you see that? Now both terms have the variable y. So if both terms have the variable y, we've got a problem. We need to take out y as a common factor. Right. So if I take out y as a common factor, then what am I left with now? If I take out y here, I'm left with x squared plus 1. Right, because y times x squared is x squared y, and y times 1 is y. You can see that. And on the left hand side, I still have my dy over dx. The fact is now, on the right hand side is just one term now. This is regarded as one term. Right, it's multiplication, so it's all regarded as one term. But in the previous step, there were two terms. You can see that. Now, since it's multiplication, I can use division to manipulate this here. Can you see that? So this is dy. So what am I going to do now? Let me just do this in 2 steps. Right, so let me cross multiply first here, because remember, this is all over 1. Right, you got a fraction. If there's no denominator shown, obviously it has to be 1. So now, what I'm going to do is I'm going to cross multiply here. So it's going to be dy times 1, which is dy. Anything multiplied by 1 is equal to itself. And if I cross here, so that's going to be x squared plus 1 times dx. Okay, so basically I just multiplied by dx on both sides, if you're looking at it that way. Now, what do I need to do? The problem is y here on the right hand side. Can you see that? So I got dx here. I must not have y here, so I can divide by y now. So that's going to be dy all divided by y is equal to x squared plus 1 multiplied by dx. Now, variables have been separated. So what can I do? I can now integrate both sides. So, on the left hand side, let me just write it down here. And then I got my right hand side. On the left hand side, I have 1 over y, because you can see that dy is in the denominator, so it's 1 over y. On the right hand side, I just have x squared plus 1. So now 1 over y is a fraction. It satisfies the condition f prime divided by f. So when I integrate 1 over y, that's going to be ln absolute value of y there. And then when I integrate x squared, well, you know, this is simple. Right, that's your standard form, integrate x squared. So that's going to be x2 plus 1, which will be 3 all divided by 3. Integrate 1, that will be x, and we put down plus c. So that is our general solution. It's not difficult. You need to make sure, unless you unless you manipulate the formula wrong, then obviously everything goes wrong here. Make sure the first few steps are correct, and then your integration will be correct also. Right, so example D, similar to example C, different from that example A. So in example A, we had a fraction on the left, fraction on the right. You cross multiply in one step. Right. But for this example C, the right hand side did not have a fraction. There were two terms here. A term is separated by a plus or minus sign. So I had to take out a common factor first and then cross multiply it. So let's see what we're going to do here. So what I can do here, I can see that y and y again similar to this example here. Y is common. So let me take out y as a common factor. So I got my x multiplied by dy over dx. Take out y, I'm left with 1 plus x. Right, so that now there are no more terms now. It's just one term on the left, one term on the right. So previously when you read this, you read it as term 1 and term 2. There are two terms separated by a plus sign. But after you take out a common factor, when you are reading this, it is regarded as just one term only, because it's all multiplication here. Right, so now the whole idea is get your dx on the right, dy on the left. So let me just do extra, I'll do it step by step. So I'm going to multiply by dx on both sides. So if I multiply by dx, it's the same as cross multiplying by dx. So now what's going to happen here is x times dy is equal to y times 1 plus x multiplied by dx. So I got my dx on the right. So what do I need to do now? Okay, so I got this dy here. I do not want x next to dy. X needs to be next to dx. So I need to now divide by x here, and then x will go in the denominator. You're clear with that? And then I do not want this y here, so I will divide by y. So I'm going to do it in one step. You might want to do it in 2 steps. It's up to you. So this is what I'm going to do now. I'm going to divide. I want this y on the left. So that's dy divided by y. And here I got my 1 plus x times dx, and I'm dividing by x there. So now the variables have been separated. dy must always be in the numerator, dx must always be in the numerator, no matter which side they are you're on. Now let's have a look. Now we go back to our chapter 4, integration techniques, and we need to integrate this here. So let's put in our integration sign, left hand side and the right hand side. There, the left hand side I got dy, on the right hand side dx. So on the left hand side, what am I integrating? It is 1 over y. On the right hand side, I'm integrating 1 plus x, all divided by x. Now, on the left hand side, you can see it's an exact derivative there. The derivative of y is 1, so you know it's going to be ln y. I'm not going to write down the answer at the moment. I'll just write it down one time. Or I can, now because there are two different sides here. So this is fine. The problem is this here. The derivative of x is not 1 plus x. So it does not satisfy this condition here. So what can we do? We can try and simplify this further by separating them into two terms. Right, so I got my 1 plus x there. My common denominator there is x, so I can separate them into two fractions, 1 over x plus x over x there. Let's see, 1 over x is fine. The problem is I need to just simplify this one further. So it's 1 over x plus x divided by x is 1. And now it is ready to integrate. So now I got my left hand side 1 over y dy, and now we can work this one out. So when you integrate 1 over y, this is exact derivatives. You must be saying it here. So as I'm saying exact derivatives, when you're studying, you must say exact derivative also, so you remember, because there's many different types. You don't want to go and confuse yourself. The top is a derivative of the bottom, so that's why I take ln absolute value of the denominator. Okay. Here, same thing. It's just that we're integrating with respect to x. Top is a derivative of the bottom, so you take ln absolute value of the denominator. Well, this is a separate term, so you integrate this one separately. So when you integrate one, it's just x plus c. And you're done. This is the general solution. Right, so that was D. Let's move on to the next one. Now let's see if the examples are going to get a bit more difficult now. Let me give you a few minutes since we got time. Separate the variables, try it out. Right, so now let's have a look at this one. We got sine x multiplied by dx over dy plus cos 2y is equal to 0. So what can we do? So let's write this as sine x dx over dy. If I take this to the right hand side, so remember there's a plus sign, so therefore there are two terms now. Okay, so I want to make it with just one term on the left, one term on the right. So this is equal to minus cos 2y. Right, so I'm transposing here. All I'm doing is taking cos to the other side, so it becomes a negative. Now I can separate them. Okay, so here, if I cross multiply, if I multiply by dy on both sides, so that will be sine x dx is equal to minus cos 2y times dy. Okay, now we are used to having dy on the left hand side. It doesn't really matter, but okay, the main thing is it's separated. You got dy as a numerator, dx as it mustn't be in the bottom. Right, if you want to rearrange it and swap it, since we're used to dy on the left, then you can always copy this on the left. If I copy this on the left hand side, and I'll have minus cos 2y dy is equal to sine x. So I'm not transposing anything now. All I'm doing is copying whatever's on the right, on the left, and whatever's on the left. I can't do that because there's an equals to sign. Left hand side is equal to the right hand side. Right, so now it's similar to what you have been doing, and now we can integrate. The integration, you can see, is not difficult at the moment. So I'll put in my integration sign on the left, integrate both sides. So this will be minus cos 2y, and I'm integrating sine x. So you should be familiar with these are basic standard on your formula sheets. Writing down equals to in the middle. I just made a mistake and wrote down equals to here because we are used to writing down equals to all the time. Be careful here. Be careful with the differential equation. Your equals to is in the center, in the middle there. Right, so now when you integrate minus cos 2y, well, it's just going to be minus sine 2y all divided by 2. Okay, so basically when you integrate, if I ignore the signs here, when you integrate cos, it's a positive sign. Why? Because when you differentiate sine, it's a positive cos. Right, so this negative was just part of the question, it was there. It has nothing to do with the integral of cos. When you integrate sine, then this one is going to be minus cos. Now let's put down plus c. If you differentiate minus cos, you must get positive sign. That's how you check your answer. Right, so this is the general solution. Yes.
What if I left cos 2x and took sine x to the other side?
You mean you left it like this?
No, what if I leave cos 2x and take sine x to the other side?
It's still correct. It's still correct. So what he's saying is, if I left cos 2y on the left and take this whole thing to the right, it's still correct. As long as you make sure you don't make a mistake with the signs. Right, so you know everything is on the board. Okay, let's do the next two here quickly. Right, so this one, there's only one term on the left, one term on the right, so we can cross multiply, we can divide. So now, let's see what we can do here. So that ln x and dx is fine, because dx and ln x are on one side. Okay, if you want to swap it, it's up to you. Right, but now, the main thing is separate the variables. So what must I do now to separate those variables? The issue here is only the x on the right hand side. That is the only problem that we have here. Can you see that? Because dy is fine where it is. This y is fine because it's with dy on one side. The only problem is the x. So all I have to do is, so I do not want x there. So there's the x there. I want this x out, so I'll multiply by 1 over x. So x and x will cancel now. Can you see that? Because I don't want to go and cross multiply everything now and complicate it, because there's only one problem. Let's not make it 10 problems. You know what I mean? So all I need to do is cancel this x, so I'll multiply by 1 over x. Now whatever I do on the right hand side, I have to do on the left hand side. So there's my 1 over x there. So now I know that I have 1 over x multiplied by ln x on the left hand side times dx there. Here x and x will cancel, so I end up with 1 over y dy. That's all. It's separated now. Now it's all about the integration.
So
Yes.
what happens if I divide by 1 over y dy on the left and then divide the whole thing on the right? The whole thing on the left.
Did you get the same thing that I have now?
Yes, I'm
No.
asking.
No matter what you do, you must, let's do what you're saying now, right? So let's see, what do I have there? Ln x dx is equal to x over y dy. Now what did you say? Divide by what?
Divide by 1 over y dy on the left, and then on the right, divide
Even
by
including the dy too. Okay, so what you're saying is you wanna divide by. What you say? Multiply by, sorry?
divide.
So you want to divide by 1 over y times dy. This is what you want to do. That's fine. Let's see what happens now. Right, so if I do it on the right hand side, that means I need to do it on the left hand side. This is what he's saying now. You have to divide by 1 over y dy on the right. So what will happen on the right? Dy and dy cancel. 1 over y and 1 over y will cancel. So therefore, I will end up with just x on the right hand side, and on the left hand side I end up with ln x on the left hand side I end up with ln x divided by 1 over y, and then I got dx over dy there. Okay, now I got ln x divided by 1 over y. So I'm dividing by a fraction. So if I invert and multiply, it becomes y ln x. And there's my dx over dy is equal to x. And now, I still have a problem, right? There's nothing wrong with what I'm doing. It's just that it's taking long now. Can you see that? So now if I cross multiply by dy, I'm going to end up with y ln x dx is equal to x dy. I cross multiplied now. Can you see that? Now, what am I going to do now? Now I need to divide by y here. I need to divide by x there. So therefore I got dy. There's the y. I'm going to divide by y. Dy over y. And then I got ln x dx. And I'm going to divide by x, which is the same thing now. Can you see that? Look at this, look at it. No matter what you do, you must come to the same thing. Right, so you can see this. It's up to you. You must practice whatever you try out different ways to do it. But at the end, we all come to the same thing. You can say that. Now, can I erase this now? You want to copy this down? Okay. Right, so let's see. Right hand side, if you want to, since what I did there, I'm just going to transfer everything, all the y's to the left. So I've got 1 over y dy is equal to 1 over x, then x times 1 over x dx. Notice now, right, so now we can integrate both sides. So if I put my integration sign in now. So we haven't dealt with this one today. This one we have dealt with. Can you see that? So the numerator is an exact derivative of the denominator. So we know the left hand side is going to be ln of the absolute value of the denominator. What about this one now? This is multiplication. Okay, so we got k. This is the first type, the multiplication type, f of x to the power n multiplied by f prime x. It's multiplication. This is a derivative of whatever this is here. Right. So this is actually ln x to the power 1. F of x to the power n, your n is 1 there, if it's not shown to you. You can see that. So now, if this condition is satisfied, by inspection, it's always going to be f of x to the power n plus 1 all over n plus 1 plus c, and this works only when n is not negative 1. When n is negative 1, then we use this formula here, the ln. So now I'm going to do this by inspection again, right, because of time. You can always, for all the inspection examples, you know, you can also use U substitution. So what do I know now? I got my f of x, f prime x. So all I will do is f of x to the power n plus 1. So it's going to equal to ln x. There's your 1 here. n there, 1 plus 1, that will be 2 over 2 plus c, and you're done. That's your general solution. Right, so the next time we will deal with the particular solution where we're going to be substituting values.